All right. So this is chapter 4D. We're going to be talking about the gradient. Um, Now I have taught you this last year, but we're just gonna learn it again and then just add more on top of it. Okay. So couple things you should know by the end of today that the gradient is the ratio of the vertical change to its horizontal change. Okay. We'll talk more about this. There's a specific formula that we use. You need to know that the gradient is a constant. Okay, so aka just a number. The gradient can be positive, negative, zero, or undefined. One of these four here. And then you are going to find the gradient of a line given 2 points, or aka two coordinate points. So I'll just write coordinate right there. Okay. So what's the gradient anyway? So the gradient is literally the describes the steepness of a line. So over here, this is my line. Now, when we draw our line, like you can pretty much make little or big right angle triangles depending on how big you wish to draw them. But there's something that we use to help find what the gradient is, to find how steep this line actually is. Okay. We use something called the vertical change, aka the rise, and then the horizontal change, which is the run. So as you can see, the run is just the distance between here to here, and then rise is up and down, just like that, okay? So please remember that. Now, this is the formula that we use. M equals rise over run. You must make sure you have this formula like memorized, or at least have it in your cheat sheet somewhere. For the better part, I'd hope that you would remember this, okay? Now, there are two types of gradients that we have, that I have right here, right now. We have a positive gradient and a negative gradient. The main difference is if you look from left to right here, if you look from there, I'll write it in a different position. Look from. If you look from left to right, as you can see, our line here is increasing. So we're looking at it from this side here, and if I go across like that, I can see that my blue line is going higher and higher every single time. So this means this is a positive gradient. Now let's just go again. So if I look at it in my second graph, if I go from left to right, I can see that my blue line is decreasing. That means my gradient is going to be a negative. Basically, the signs of the gradient, they determine the direction. They determine the direction as to where our line goes. So whether it goes up, whether it goes down. Now, this only applies to a positive number gradient or a negative number gradient. Okay. Now, this is pretty much just what I reiterated, but it's here. Okay. Another way to think about it is like if my gradient is positive, if I take one step forward, I'm going to go up. And then if my gradient is negative and I take one step forward, it's going to go down instead. Okay. So I'm just going to use this as an example. So we'll just open up Desmos. Uh, Probably not this one. I just type in Desmos right here. I'll just fix this up. Desmos. Okay, so this will now become. Uh, Whoops. Let's just fix this up. This now just becomes y equals negative 2x. So let's just double check that's what we're doing. Negative 2x minus 1. As you can see, I have a negative gradient right here, negative 2. And we can tell by going from left to right, my y values keep going down and down and down and down and down. Now, let's change it to a positive 2. As you can see, my direction changes. It is now going upwards every time I move from left to right. Okay. So that's what you need to know most importantly. Now, here are some different types right here. You have something called a zero gradient. A zero gradient is literally the horizontal line only, which is what I taught you in chapter 4C. Now, the general equation of a straight line, of a horizontal line right here was y equals c. Okay. So looking at my line right here, I'm just going to assume every step goes is 1. This is my axis right here. This is my axis. For my green line, right there, I can see that it's just going horizontally across. So my general equation is y equals to 1 in this case, okay? So every time you see a horizontal line like this, it's a zero gradient, okay? That's what you need to know. So horizontal line. Now, an undefined gradient is for vertical lines only. So that's my purple one right here. My purple line, it's a vertical line. It just shoots straight up. We don't have a gradient for that. It doesn't exist, so we just call it undefined. So that's what you need to do, okay? So you might be asked some questions where it's like, here's a graph, just state whether it's positive, negative, zero, or undefined, then find a gradient where possible, okay? So let's just have a look here. So looking from our graph, if we go from left to right, we can see that our graph is increasing. So we know it's going to be a positive graph. It's a positive gradient. And then the second part of the question says, find the gradient. Now, all I'm going to do is I'm going to make myself a right angle triangle. So I'm going to use my red pen to differentiate because I don't want people getting confused. So I'll just decide to make a triangle like that. Now, you're going to ask yourself, what's my rise? And then what's my run? Now, it doesn't matter how big or small you make the triangle, obviously, just make sure that it makes sense, okay? So, looking at my graph here and looking at the scaling, I can see that my rise is 6 because every step I count here, it's increasing by 2 every single time. Now, let's have a look at the run. So, I'm looking at the steps right here. It looks like it's going by 1, so you're just finding what's this distance. This number is negative 1, by the way. So what's the distance from negative 1 to positive 2? Obviously, we can tell that it is 3. So now we do m equals rise over run. Since we've already identified what rise and run are, numbers wise, we can just substitute it in. So we're left with 6 over 3. And what's 6 over 3? That just becomes positive 2. Therefore, m equals to 2, just like that. And that's how you do it. Now let's have a look at this one here. Stay over the green. Same type of question, just a different graph. So have a look. Left to right, my y values are going down. So we know it's going to be a negative gradient. Now, let's just draw a triangle. I typically like to use the x and the y axis to help me draw my triangle. So I'll just say Use X and Y axis to draw right angle triangle. This will just make it easier to count like your rise and runs. It just makes it 10 times easier. So let's just go through the rise. My rise, it looks like it's going up by one every time. So one, two, and three. So my rise is three. And then my run here, it's going by ones as well. So starting from here, one, two. Actually, I'll use a different color. I'll use a different color. I think that'll make it easier. So one, two, and then one, two, three. So I have my rise is three, my run is two. So now let's just use our formula. M equals rise over run. And let's substitute the value. 3 over 2. Obviously, 3 doesn't divide by 2 perfectly, so you can just leave it as a fraction. Leaving it as a fraction is perfectly fine. But have a look at what I found. Like, I've found that this is a positive, though. This is a positive gradient, though. But earlier, we established that it was a negative gradient. So what do you reckon I should do? I should, in fact, put in a negative sign. Now, it doesn't matter where you put the negative. If you really want to be pedantic about it, put it in the middle between the two, between the rise or the run. It doesn't matter. Just put it in the middle there. This is the same thing as if I put the negative on the top, and it's the same thing as if I put the negative on the bottom. It does not matter. As long as you have the negative in, but if you really care about appearances, this is the way to go. Okay? So my gradient for this line right here is negative 3 over 2. Now, let's have a look here. Looks like a horizontal line. My line is at y equals to 4 because that's what the general equation looks like, y equals c. And we know it crosses through the y-axis at 4, so it's just y equals 4. Now, we mentioned earlier that a zero gradient is for a horizontal line only. As you can see, we have a horizontal line, so it's a zero gradient, number one. So m equals 0. And finally, we have this. We have a vertical line. Now, where is this at? This vertical line is at x equals 2 because it crosses the x-axis at 2. Now, let's just go back to earlier. What did we say vertical lines gradients were? They are undefined. Okay? They are undefined. So we are just going to say m equals undefined. And you are done. Literally. Now, if you really want me to get into why the vertical line is undefined or why the horizontal line is a zero gradient, I can talk to you in private and then we'll just go through it. Now, finding gradients using two coordinate points. Step one is pick out two coordinate points that are on the line. So this is assuming that there is a graph and no graph given. Like assume graph given. But sometimes they won't give you. Sometimes won't give you graph. So they may give you graphs, but and they may not at the same time. Now, if you're a bit stuck and you don't know how to find the gradient, you can use this right here. Um, since you have picked out two, since you've picked out two coordinate points, you're going to label them as x1 and y1. Now, if you're wondering what they just mean the first coordinate point and the second coordinate point that you pick. So I'll write it so it's a bit neater. So this is your first coordinate point, and then this is your second coordinate point right here. That is all it means. Okay. Actually, I'll use a different color just to make it easier. Oh no. I'll use blue. And then I'll use green for the last one. You are now going to use this formula here. M equals y2 minus y1 over x2 minus x1 here. In simple terms, this pretty much this pretty much means the rise, and this pretty much means the run. They're just one and the same, but they're just written differently. So one of them is just a bit more mathematical than the other. Um, but that's about it. So let's just go through some examples now. All right, so let's just go through some examples now. Here we go. So I've got A is 3, 4, and point B is 5 and 6. So I'm just going to label them as X1 and Y1 first. So I'm going to label A as my first coordinate point, and then I'm going to label 5, 6 as my second coordinate point right here. I'm now going to start off by writing my formula, M equals Y2 minus Y1 over x2 minus x1 here, just like that. What we're going to do next is substitute. We're going to substitute each value based on their respective position, okay? So y2 means 6 minus y1, which is 4, over x2 being 5 minus x1, which is 3. The next thing you're going to do is just simplify the numerators and the denominators respectively. So in the numerator, I have 6 minus 4 being 2, and then 5 minus 3 in the denominator being 2 as well. And 2 over 2 just means 2 divided by 2, which equals to 1. Therefore, your gradient equals to 1, and you're done. You're going to do the same thing here. So I'll just label C as x1, y1, okay, the first coordinate point, and D being the second coordinate point right there. Now, when you do this right here, you got to be careful with your negatives. So just be careful when you substitute numbers in, okay? So we'll start out by writing the formula. Now, typically don't work across, work downwards, okay? It just makes life 10 times easier. So let's just substitute right now. So m equals to, what's y2 here? I have negative 3 minus y1 being 6. Put that over x2, which is positive 1, minus x1 is negative 3. So this is what I mean by be careful. So you actually have to do minus negative 3. Now, obviously, when you do math, when you see two sides next to each other like that, you have to combine the operations. So two minuses make a plus. So what I'll do is I will rewrite this fraction again. 1 plus 3. If I bring it over here, equals, let's simplify the numerator. Negative 3 minus 6 equals to negative 9. And obviously 1 plus 3 equals to 4. Now, 9 can't divide into 4 perfectly, so you can just leave it as a fraction. So your gradient is actually negative 9 over 4, and you are done, just like that. So please take into account all of this. If you're stuck, feel free to reach out. I'll be available Wednesday after school, okay? In the library. Take care. These are the questions you got to do. Make sure you get it done. Detentions, yada, yada, yada. Goodbye.